Good afternoon, everyone. I'm not going to use a mic. I don't think we need one. I'll just stand on this side. You guys can hear me okay, right? Okay. So we are going to talk today about patterns and test automation frameworks. I'm Anand Bagmar. I work as a test practice lead at ThoughtWorks. I've been doing testing for a long time, and I do anything and everything when it comes to quality of a product. I get involved over there. My contact information is on the slide. Twitter ID is there. So if you want to contact me after the talk, then we can always communicate in either way that works out. So what really is test automation? Can anyone say what is test automation? Eliminating manual portion. Okay. Why do we do it? Sorry? Okay. Automating the manual steps that are there. Reduce regression efforts. So, okay, that is all good. Why do we do it though? Another main reason, it's a safety net for us. Right? It's a safety net for the team to say this has been validated. We have built it as per requirements. And if I keep running these set of scripts again, over and over again, we know what we expected to work earlier, or what we validated was working earlier is continuing to remain the same. Right? What most people think of when they are doing test automation, they're thinking about the functional side of it, the UI side of it, whatever the user sees, how can I automate those aspects from the scripting perspective? Unfortunately, that is not what test automation only is. It could be any type of test intent that you have identified and you have automated that. It could be at a unit test level, it could be at a functional level, it could be security testing, performance testing, any type of testing might come under this purview. For the focus of this talk, yeah.
Like you said, that automation is a safety net. Would that definition hold true in this scenario in today's world? Because I think most of the team is moving towards the continuous integration and continuous delivery, and automation plays a major role.
Correct.
It should not be a safety net. It is the also, if I go by my definition, I cannot have a continuous delivery without having a robust automation framework in place, eliminating the manual testing on.
Yeah.
Like if it would be if I am a product owner, I want my code coverage to be 100% automate so that I could be very sure of whatever the code I am pushing in get would be deliverable.
Okay, this is one of the prescriptive fragile practices, if I may so say, what Naresh was talking about earlier. It's a practice. You have to choose whether it's going to add value to you or not. Okay? If I may quote what Naresh just said when we were having this conversation, on the platform that he's built, he has very limited, if I may say so.
Zero.
Okay, that's limited. He's got zero automation coverage. Does it mean you cannot do continuous delivery? I think he's making changes per check-in that is happening. It's going live. And I've been using that platform myself a lot. Many others are. The point is, any practice is a best practice in the context what is working for you or not. It can become fragile or anti-fragile based on what it is doing. I'm going to use a lot of that. That's okay. So it is still a safety net. In continuous delivery, why do you need test automation in various ways, especially if the product really grows, scales, a lot of dependent systems. It adds to that safety net. If it was working earlier, something downstream is not going to start failing because of it. Doesn't mean you need it. Without it, you cannot go live.
So if I go by your example that the narration is zero automation, so where is the safety net? The safety net is gone, I am bound to fall. Or what is
Has he fallen in 2.5 years? It's a risk that teams need to take. For the risk of digressing from this topic, it's all context specific. What we are saying here, I don't want to get into that debate right now. It will derail this core conversation. But the point is, you choose practices which are going to add value to you and your team. And if the answer is yes, test automation is going to add value, you are in the right session. And in that context, we are focused on the UI aspect of it for this session. Mostly, this will add even more value. But we can continue that conversation post this talk. Okay?
To kind of add a little bit, so when we talk about safety net, I also think of automation being a source of capturing knowledge of how the system works. So
yeah,
there's
self-documentation.
Self-documentation aspect.
Absolutely.
There is also impact aspect. So a lot of times when you have a good coverage go and make a small change and you see what is going to get impacted.
Correct.
So it helps in like a lot more aspects as well.
Absolutely. Absolutely. And that's the safety net that we are really talking about, right? That you've ensured as you've built the functionality. If you're following TDD, you have written the test first, then you've written the code behind, which is great. Even if you have not, if you have validated something has been developed well, and you have the test coverage to support it, you know if something breaks downstream or changes downstream in a form of automated test failure, you will know something has changed. Maybe the test is just outdated, it's fine. But you know about it, it's not just gone under the covers. Okay? That's what we mean by the safety net. So, what we are going to talk about today are certain principles and practices that I have come to realize which help in building a good test automation framework. And we'll talk about some of that today. So one thing that you have to keep in mind, test code is code. You should not be distinguishing between a test code and a product code. You have to treat it with the same respect. What that means is you need to use the same design patterns that a developer would use when implementing code. Similar kind of, but yet appropriate practices need to be brought in on the test framework side as well. Which means you need to have proper abstraction layers also defined, and the basic principle of coding is refactor, evolve, learn from that, and extend as required based on the functionality expected from your framework as well. Last bit, which helps a lot I have seen, is pairing. Now pairing, again, predominantly a development practice, but especially when you are writing code and complex logic regarding the framework more so than anything else, get a second pair of eyes to actually work with you when implementing it. It will help you ensure you are building a validating system correctly to test the product well. So don't leave that aspect out. It adds a lot of value. Now, if these are the principles I live by, what are some practices that really help me in this, in having a good test automation framework? It is important to have the framework configurable. Configurable from various different aspects. Do I want to run it, validate the functionality from the UI or through web services, or run it against one environment or the other, one browser or the other, whatever that might be. You have to have it configurable. Ensure you're not doing any copy paste. I wish there was a way to disable Control-C, Control-V or Command-C, Command-V, because that is what creates bad code. Instead of using the refactor principles, you're starting to duplicate the code and you are never going to get time to make it clean again. Spend that extra effort initially itself and make sure you're writing good code. Continuous integration, we already spoke about that. It's no use having tests automated if you're not going to run it on every check-in that is going on. On that note, slight digression again, the only reason why we have different types of functional tests, smoke, sanity, regression, is because they are terribly slow. We don't have that classification or categorization in unit tests or integration tests. We just call them unit tests, integration tests. They run fast, they run quickly, they give you quick feedback. Just because functional tests take so much time to execute, you need to first build and deploy a product, set up the environment correctly, then start running the tests. If you have tens of tests or 100 or thousands of tests, imagine the kind of feedback cycle you're looking at. So that's why you start classifying, this is my smoke test, I'll run this first. If this passes, then I'll do something else. So a way to eliminate that is keep minimal functional tests. That's the first place, the first thing. Okay? You have to think about test data. Very less importance is given to thinking about how are you going to create test data, manage test data, use test data, reuse test data, and change it as the product and your test framework also grows. You have to put in some initial thoughts without over-engineering, put in some initial thoughts about how that needs to be done. And think about what are the tools, utilities you would need in your framework to help you understand what that execution is really doing. Have proper logging, maybe take screenshots, maybe have video recordings if required. Whatever is essential from your framework perspective, if you spend enough time on it at the right time as your product test framework evolves, it will help you a lot, because last thing you want to do is, oh, test failed, but I don't know why, let me rerun it again. If the test has failed, the test actually knows what has gone wrong based on what it needed to do. If you have sufficient information in that, just looking at that will help you get to the root cause much more quickly. Okay? So think about all these principles and practices, whichever makes sense for your context when you start building and evolving your test framework. Okay? enough said about the test framework. Let's get core into the topic of patterns. What is a pattern? It is a template of sorts that you'll keep on applying in different forms whenever you really want it. Developers use a lot of these patterns. There are, I don't know how many patterns are there for that matter.
23.
23 patterns. That's it?
No,
Yeah.
More than 206.
33 with the Django 4 book. Yes, possibly.
Okay. So there are a lot of patterns. I don't know those patterns myself completely. But I do know there are certain patterns which help a lot in building the code, product code, making it reusable, evolve it better, and actually achieve the functionality in the right way. Since we started off saying that test code is also code, it has to be of the same quality. In fact, someone, when I made that statement, commented from the audience saying it has to be better than the product code quality because it is validating what production code is going to be doing. So it has to be better quality than product code itself. If that is the case, you have to look at certain reusable patterns which help build a framework in a better way. Okay? Let's look at some case study to really understand this. Before we look into the case study, what is a general spread of roles in this room right now? How many people involved in, how many developers in the room? Any developers? Good few developers. Testers? Of all these people also doing automation or doing both automation, manual, both side of things? Yeah? Both sides, okay. The other roles, what are the other roles in the room right now? Leads, managers, BAs, managers, okay. Okay. So I'm hoping the managers are also on the technical side because what we'll be talking about next is we'll be looking at code snippets. It's not really what the code is doing. I've pulled in code from various different sources and experiences just to demonstrate certain points about what patterns can help us do. So don't get lost in the code side of it. If you're not able to follow it, that's fine. The point is understand the intent. And it's good we have some managers over here because managers are the one who will help the teams achieve and write the good code. Otherwise, managers typically will say, okay, we need to keep pushing and getting functionality done or get tests automated. Don't worry about tech debt or writing good code, just copy paste and do these variations, right? It's important to understand the impact of these and what it would be. So let's look at an old Amazon.in homepage. This is pretty old for that matter. What we'll be doing is thinking about how can we automate this page in various different ways as the product evolves, okay? So if you have to apply our patterns to it, the first thing from a test automation mindset, what you would think about is, if this is the page that I'm interested in, what are the different snippets that I can really have out of it, functionality-wise, right? I've got search bar, I've got menu bar, I've got advertisement in the menu bar, I've got some gallery of sorts, and recently viewed items over there. Then I've got in some items from the menu bar, I've got a further deeper set of functionality that comes out, right? And more advertisements over there. So this is what the product is doing or is going to do as we evolve into building this functionality. So let's look at the journey of how you can do test automation for such a product. So if there is no test automation right now on this Amazon.com page, how would your first test potentially start?
If you also look at this point around what is the riskiest thing, the most likely thing to fail, or you would try and tackle it?
So I'm not focused on the prioritization or intent of the test. I'm assuming that conversation and thought process has happened separately. Assuming you have a set of functionality, how will you build your framework and structure your test automation framework around that? What are the different things you can potentially think about? Okay, so let's look at the first code sample. This is my first test that I have. This is a Ruby-based test. And my first test potentially can just start like this. The intent, let's assume the intent is I want to search for something. The code is, of course, not reflecting that. Whatever the intent is, the first thing I potentially start doing when I have to start building my automation framework is write some wrapper test of sorts, whether it's a JUnit, so it's a test annotation, or in this case, it's a test or describe RSpec based test, whatever it might be. You have your basic structure created, and then you start saying, okay, let me instantiate a driver. In this case, it's user, and which browser I want to use, what is the homepage URL that I want to achieve for it, and what do I want to do with that, right? So I open the browser, go to that page, I want to do certain functionality out of it. Everything is there in one test itself. A good starting point, just to ensure that your basic structure is set up, your driver is set up correctly, browser is set up correctly, you're able to hit the home page and do certain functionalities out of it. Is this a good idea to do for each and every test? Exactly, right? You'll end up doing the same thing in each and every test that you want to repeat, right from starting creating a driver and which home page it is. And if the home page URL changes, you have to go to each and every test and see what needs to be updated for that. And that's where the first pattern for test automation framework, one of the most popular patterns, comes out. That is a page object pattern. Have we used page object patterns before or know about page object patterns? No? Very quick summary of that. What it means is you have to model the page functionalities or other functionalities in form of pages in code. Each page object in code will represent what the page under test is doing. So for a home page, I might have a home page class, and in that class, how to interact with that home page, that's what would be implemented over there. It simulates user actions. The user is clicking here or is entering this value in the search field and searching for certain item or whatever that functionality might be. It is simulating user actions. It enables a one-place change. If my search functionality has changed, the search text box has changed into something else, I can just go into this one page which is implementing the interaction with that particular functionality, change it over there, and everyone else will automatically start using it. It also reduces the duplication in code. So the menu bar, for example, what we saw, it is there in each and every page on Amazon site, whether it's on a product page or a payment page or whatever it might be. So if I model the menu bar separately, I can reuse that in various different fashions in whichever page it is really coming up in and do actions on that. So it is reducing duplication of code. I don't have to implement menu page interactions in each and every page, home page, product page, or whatever it might be. And the other aspect is what it results in, though the home page is one big monolith page, it really is a composition of various different aspects of it. It will have menu bar, it will have advertisement of different types, carousels, recently viewed, whatever it might be. So it becomes a container for various different snippets of page which really form a home page for that matter. Okay? With me so far? What the page object pattern is? Let's look at a code sample, what that really means. So as your page is now evolving, and now we have switched to a Java test, you have your test intent which is going across various different snippets of pages. It might be a single web page app for that matter, right? It's going through various different snippets of pages. That's what your intent is showing. And the implementation of that page will have everything related with how do you interact with the page. The page object is a dummy object. It has no brains of its own. It just knows how to retrieve information from that specific page that is under test, or how to do actions on that particular snippet. If any part of that has changed in the product, in the actual page implementation itself, the page object cannot handle it. Okay? It is dummy. It should not have any logic in that. You see?
It loads the complete page, right? It looks for our complete. It takes a one snippet and then it searches for the objects and do that. It performs that. That's what the page pattern.
Correct. Yeah. So page object, home page will have menu bar. So how do I interact with the menu bar? It will say menu bar, click, sign in. Something of that sort, right? The implementation in that page will tell you how to really interact with that. What ID to use, whether I want to use XPath or CSS or anything else for that matter, right? The page implementation will have it. Now, if we do not break down the page into smaller snippets, this is what ends up happening. This is my home page, and this page has got almost 1,000 lines of code in it, how to interact with that page. Now, this may be fine for certain cases, but in most cases, at least for me, I find it very non-usable or very limiting in use, because now, yes, the IDE is very powerful. RubyMine in this case or IntelliJ is very powerful to find out what you're looking for, but it's still not very easy to manage. I've got too much implementation logic in this page for me to say, I wanted to do this one particular action. I'm not able to find what I'm looking for. Let me just implement something else. And any programming language will let you do that as long as the method name is different, because the intent is different. That's what it might seem. But the implementation is actually the same. I'm still looking for the same element and still doing the same action. I'm just calling it in different ways. And what has happened as a result? Now you've got two implementations doing the same thing and you have no idea about it as well. And that becomes a problem. But as the framework is evolving, this is a good next step to get, because now what you have done is you don't have instantiating the driver in your test itself, the implementation itself. You're not interacting with each and every element directly from your test. You've made it into reusable components in form of page objects. Move the functionality over there in terms of what actions I want to do, what verifications I want to do out of that, or what data I want to retrieve out of it. And that's a good next step. Okay? So as the framework has evolved, what we really see is the architecture sort of looking of this sort, where you've got your test intent, which is a JUnit test or your RSpec test or whichever type of test it might be, which has your assertion actions, what you want to do. I want to do this action on this particular page. That might be there. This is what assertions I want to have as part of it. I expect to be signed in after doing login, right? All the assertions, verifications, and the rules of your product would be implemented here. How do you implement it? How do you really get individual actions done? It would talk to your pages and say, okay, home page, this is what you need to do. Menu bar, this is what you need to do. Okay? You would also have resources of sort which says, okay, which browser I am working with, or what is my environment configurations that I have. Those things potentially you start separating it out now into a separate set of files, whatever those types of files might be. And then you would also have how do you really interact with the driver. The page object would interact with the driver. If I have web services, how do I interact with that? If I have any logging utilities or any other utilities, how do I interact with those helpers? So your framework has now started to get evolved in this. With page objects, you can make it even better for that matter as you keep evolving. Now your pages, you can separate the entities. Entities in the Amazon case would be products, would be users potentially of different types. It could be an unregistered user, a registered user, maybe some form of admin users, for example. Whatever personas that can interact with your product, and whatever other entities, models that might exist. You might want to start modeling that separately out of your page itself, because now you can interact with it better and reuse it in better fashions. And your helpers utilities can also keep on getting much more extended, where you will have things like loggers, resource handlers, custom reporters. You want to see reports of different sorts, and also web service utilities might be there. Okay, so it's always a step-by-step process that as you get more and more test intent automated, how do you keep your code more managed? If I just need to do one test and that's what is sufficient for me, the first example I showed might have been sufficient. You don't need to build a complex automation framework for that. You have to understand the intent. Okay. Now, as our functionality has evolved, as our test framework has evolved, we've now started to create smaller snippets of pages, which is doing exactly what that snippet might be doing. So tying it to the Amazon context, my search bar is a separate page entity itself, a page object itself. How do I interact with that? It might just have one method in it to get information or to do certain action on it, which is fine. It's not about I need to have at least so many methods or so many lines of code before I break it out. Whatever is a logical breakup, that is what you need to focus on. And that logical breakup will then come together. You can use composition patterns or whichever other patterns might be required to build a proper page together and have all the functionality over there. So in this case, we've got various different types of snippets, search results page, save search, browse by vehicle, basic search, advanced search, whatever that might be doing, and it has only the functionality that it can interact with. Okay, this is search related. In partials, again, you can break it up in whichever way your functionality can be broken up. Now this also works great because now you have really modeled your test automation framework closest to what the product itself is really doing. You've broken it up based on the users, the entities, the snippets, whatever might be there, and it all works great. But there are some limitations that arise out of this pattern as well. And these limitations do come across when the number of tests really start growing. The first limitation is the test intent starts getting polluted. The test intent has to be about what is the impact of this UI level test that should be there on the product. The intent, the impact of this test should be what business value am I trying to achieve out of this. It's not the granular functionality that I'm looking for. Is this a checkbox? Is this a radio button? Am I seeing this value correctly in particular label field or whatever, right? What is a business value that is important for me to validate? That is what you're trying to automate at this UI functional layer. And if in the implementation you have all these details, the intent gets lost. As Naresh clearly said, these become your documentation of sorts, what the product is supposed to be doing. Can you really understand that documentation based on all these other implementation details that are there? That becomes a first problem. Second, there could be various variants of functionality, right? Search for this existing product, search for non-existing product. What is different? You're doing the same set of actions. I'm searching for something. In one case, I expect to see search results. In other case, I expect to see found 0 items matching your product. So the assertion value potentially is going to change. What this means is to implement this functionality, I still need to duplicate the same intent everywhere. Just the assertion value has changed. Now, my code duplication has started. Because in the traditional page object pattern implementation, what you would have in your intent, search for existing product, you would implement certain things. Oh, now I have got a new functionality, non-existing product. Copy paste the test, change the test name, change the assertion, I am done. Such an easy way to add test coverage to it. But what you have done now is duplicated that implementation of that intent. And that becomes a problem. Also, the intent becomes very imperative. Imperative means now you're talking about user actions, right? Go to this page and do this action. From this page, verify this certain details are there or not. From search results page, I should see no products found. Very imperative actions in various ways, right? And that is not really good because again, you're not getting the true business value out of it. You'll understand the UI flow of the product. You'll not understand the business value, what you're trying to achieve out of it. Maintenance challenges also start coming up now. Now you've got duplicated tests of various different sorts, implementation-wise, with different intents. And as the functionality evolves, you now have to find out by chance or spend a lot of effort going through all the tests to say what has really changed in these tests because of the change in implementation. A business logic has changed potentially. I don't know, the UI flow might have changed. And you have to spend more and more time looking at code. And most often it is, I'll run the test, whichever fail, I'll look at those tests and I will update them. That becomes a course of fixing these. As a result, scaling challenges happen. You might start off with one test. It might work up to 10 tests. You evolve the framework into a different pattern. It might work up to 100 tests. In many cases, I've heard teams having thousands of tests, which is a sad thing, but that's a reality again. And this will add to the problem because now you've got so much duplication, you don't even know where to look and where to optimize it. And that is the reason where I started calling this a business layer page object pattern. This is nothing new, nothing rocket science. It's just a natural evolution of the framework to say, how can I overcome the challenges that we spoke about earlier in the page object pattern? So what we are trying to do with this pattern is our test intent, we've now broken up into two aspects. The intent remains a pure intent from a business layer, business operation perspective. I want to, if I go to Amazon site, I want to be able to search for a product, add it to my shopping cart and buy it, paying using whatever payment mechanism I want. That is my business operation. I don't care how it is implemented. I don't care really what my assertion needs to be. As long as I can achieve those business rules, search, add to shopping cart and pay, I know my business rules are validated. That's what is important to me. The business layer is where implementation of each of those will come in. How do I search? That's a business operation. Search is a business operation. How do I search? To search, maybe I need to talk to 3 different types of pages or snippets to achieve that search functionality. Now you're starting to break it up into various different layers. Intent remains business layer, business operations. The business layer or the domain functionality is talking about how to implement each and every of those actions, the business rules rather, and implement and also verify that the implementation has gone through correctly. Now the assertion is not really at the test intent layer. The test intent is actually the business rules just in sequence what is supposed to happen. If the first business rule fails, the next one is not even going to go through, it's fine. And the pages, entities, models, everything below remains the same. So just the top layer we have now separated out. And what this means is, let's look at an example for this as well. In this case now, I'm using a Cucumber JVM example. And this is a very, very simplistic example. But all I'm really trying to talk about here is what is the business set rules that I want to implement, that I want to achieve. And maybe it needs some data to be specified as part of it, but that's a separate thing we'll talk about. When you talk about these business rules and when you look at the implementation of these, so if I look at the implementation of this, all I really have over here is in each of these methods or steps that tie from the intent layer to implementation, I'm just calling a business operation directly in the business layer. Now my intent is just about calling business layers, business operations. That's about it. The implementation of these business layers will talk about, this is web service example, so I'll take another one. The implementation will talk about which pages do I need to talk to, what orchestration do I need to do to achieve that business operation. The business layer can also say this is a complex business operation, it is made up of smaller business operations, let me call those instead, which will in turn talk to specific pages to get that implementation done. So now the implementation details have started moving out from the intent to the business layer, which means if my business operation is evolving or there's a more complex business operations, I don't need to have the details inside it. I'm just going to call those smaller set of business operations to achieve it or talk to page objects directly to get that implemented. Okay, I'm not duplicating code anywhere. I'm just evolving it to say, okay, you logging rather to search or look at my past orders. What do I need to do? I first need to go to login page, login. From there, I'll go to my orders and then I'll see. That's all I need to do. A business operation is view orders as a registered user or view past orders for a registered user, which will mean talk to various different business operations to get that implemented. And that makes a very big difference in terms of as the framework is evolving, how can you move the code around to make sure any change that happens in your functionality, technical change or a business operation change, the changes need to be made in the test framework at very specific points and everyone else will automatically start reusing it. That is the intent. Also the other aspect which the page object pattern and the business layer page object pattern helps achieve is you don't really care whether it is hitting the UI directly or it is using web services or whatever it might be. The intent has remained as a business operation. The implementation can say, based on whatever flags you might have or specific terminology, to say, I want to achieve this functionality by hitting a web service or by going through the UI and implement it directly. So it makes it very powerful in that way. Questions so far about this? Okay. So the advantage of evolving into this pattern is now you start focusing in your intent level itself, the test specification level in terms of business operations. You're no more talking about granular operations on the UI. You're not talking about the UI layout and the UI flow to achieve certain functionality. You're talking about what business operations you want to focus on. Your test pyramid layer test pyramid also remains same because now you're focused on the top layer, which is the journey aspect of it, the business impact aspect of it, and you're moving the smaller granular test to the lower layers just by consciously thinking about it. Otherwise, you would just copy paste, change certain things, and you're adding more tests to your UI layer, which is going to become slower in feedback. The abstraction layers allow the separation of concerns in what implementations happens at what point in time. As a result, the changes also remain isolated. And maintenance and scaling becomes easier. Note I'm saying easier. I'm not saying it will become easier. It is code. As you write more code, there will be more maintenance challenges coming across with it for sure. But as the framework really grows, this will help you make changes where really required without affecting anything else. And at the same time, any changes made will be automatically used by everyone else who's consuming that object. Okay? So this is from a pattern side when specifying test and building your test automation framework itself. Let's look at certain different aspects of test frameworks, such as test data. Now, we need to think about test data differently for various reasons. Because data is complex. In some cases, it might be easy. I want to get the weather for this city. It's an easy thing. But if we go back to Amazon example, there's so many different things we are talking about test data. How do I specify I want to search for a particular phone having these specifications? Or I want to buy some toy for a toddler. Each product has different criteria. Each product needs different metadata information for it to search for it and say, yes, this is what is correct or not about it. The user details might be different for different sorts. So you need to think about what is important from a test data perspective, and that given the data is complex, given that we need to mimic real data, it's not that I want to search for any product. I want to search for product based on that specific criteria. How do we specify it? In some cases, it might be static. I want to search for a 1+1 phone having these specs for it, based on memory, for example, or whatever else. So I could hard code that data in my intent, or in some cases, I want to be able to search for different types of products. How do I specify that? I don't want to create new tests just because my data has changed now, or I want to search for different things. You have to think about these aspects. Also, this data can be reused across other tests as well. If I have written a test for a particular product specifying that data, someone else can very easily reuse that data as well. Is it going to be complete enough or not? If that person changes the data, how does it affect me? So you have to think about these aspects. And in many cases, data also needs to be unique. If I want to create a user, I cannot create a user Anand every time. Maybe my business logic or my product functionality doesn't support that. So I can't keep on changing my test data every time to say, okay, it's Anand 1, Anand 2, Anand 3 every time. The framework needs to be able to handle it in various ways. Again, these are driven by requirements, right? And data can be nested. Nested in form of, okay, a user has these things. If it's unregistered user, there are certain other properties to it. A registered user has certain other properties to it. Admin user has certain other properties. So how do you really nest data to maximize the benefits of reuse for it? Okay. There are different ways you can specify this data. You can specify it in test implementation. You can specify it in the intent itself. It might come from code that in the page object itself, I have got it specified in various ways over there. It can be in external files. And given all these different options, you can specify it in various different ways as well. You can specify it in Excel, which can again give complex data. Excel, which also means CSV in various ways. You could use that. You can have property files. You can have XML files, YAML files. You can put in a database. A database can be a test database or a copy of production database for that matter, whatever works for you. It can be JSON, or maybe there are various other ways you can specify it as well. Clearly, data is not easy to manage, create, and specify. Based on what you really need to do in your test framework, think about it and how you can evolve into that structure which can help you manage it better and evolve and maintain it better. So the criteria, in my opinion, has to be easy to specify. It has to be easy to consume. It doesn't help if I have specified in a notepad when no one else can really consume it well. You should be able to override certain aspects of that data if required. Again, it has to be a business case, and it has to be usable. You cannot create it so complex that you don't even know how to use it. As a result, anti-patterns, and you start creating your own different forms for it. Okay. So moving quickly in interest of time, think about consistent ways to specify test data. Read the data as business functionality in various ways. I want to create a user of this particular type. That can be your intent, and specify certain values in your intent over there, which will help you achieve that. Override as appropriate. That will add a lot of value and power to your test framework without having to duplicate the data itself. And in some cases, it might be easier to create some DSLs, meaningful domain-specific language to say, I want to use a registered user. What does a registered user mean? That's a DSL in form of a data that you can create for it. And use this DSL in the implementation, which helps a lot. In some cases, it might help to build utilities on top of data objects to say, how do I build this particular data object? How do I copy this to create another type of user for based on the same data? Or can I find particular user from my test data for based on certain attributes? You can have a lot of those. Okay. So that was about data. Last bit, locators. Yeah.
Quick question on the data. Any recommendation on do you start with a clean database, fill it with seed data, and then kind of take it from there, or start with the snapshot of the database and start from there? Any recommendations?
So question is any thoughts on how do you start with the data, clean database or a production copy or whatever it is? I think it really depends on the data that you're interacting with and the product under test. In one case where we were relying on data coming in from a mainframe, there is no way we could have created that data without spending a lot on mocking that complete set of database, right? So what we ended up doing is we'll query the database, which was a mainframe production like data. We'll query it based on the criteria we want, and we'll use that. So it's still dynamic data. The static aspects are what attributes we want to query for it. So that works well in some cases. Okay. So it's all context dependent. So locators, you can have locators. How do I find certain aspects of elements in the page? You can have it in separate files or in the page objects itself. Either way, what works for you. But think about these different aspects because it means not just how you are going to use it, it's also what is going to be used by others. And remember, your test framework is going to remain for a long time as long as the product is living, which means it has to be usable for that duration as well. So think about these aspects. So which pattern is the best to use? Either for building an automation framework or for your data or for locator? Answer is it completely depends on the context. Context of the team, the life of the product, what you're trying to do with that product under test, and what is the eventual goal of your test automation framework as well. And that would really do that. That will help derive at some answer. There are certain best practices. Best is in quotes because it depends again on the context of the team, what will work or not. But think about these various different aspects when you're building your test automation framework and choosing the strategies for building the same. Okay, I've got references for some articles over here, what we've spoken about. And of course, we can continue having conversations later as well. Test automation framework is complex. It's not an easy thing to do. You need proper understanding of code to build it. If as testers, as automation engineers, we don't have the proper expertise in building a good framework, we don't understand data design patterns well, take help from developers, learn these patterns. If you cannot write good code, you cannot build good test automation framework for sure. It will not be maintainable or scalable in the long run. Okay. With that, I'm done. I don't know if we have time for questions. I believe I might be holding you all from lunch as well. But this is what I wanted to share. It became quite fast. A lot of things to share, a lot of code to look at which didn't make sense at all. But hopefully the concept came across.
Just a quick question. We have BI applications wherein we are using the Microsoft BI platform and the dashboarding tools. This name Tableau and so from the BI perspective, we are just looking for the test automation because most of the testing is done as a manual. But if we want to look into that perspective, so what do you recommend? Is there any case study we can go through or any suggestions on the tools?
On top of my head, I cannot name any because I have not used any of those platforms. And unless I really look at the product under test and what things can be tested or interacted with the application below the UI layer, it is going to be very difficult. If we just focus on the UI aspect, it is going to be very tricky because again, don't know what type of interactions are possible with that particular tool set. So it might be easy, it might be difficult. I really have no direct answer for that.
Because we have like reports, mainly reports, SSRS reports, so that's from the UI perspective, or the dashboards, the Tableau dashboard. So there is a navigation and lot of data validation. So basically there will be two things that I can think of is data validation and navigation. And understanding the business rules being coded into the dashboard is being done properly.
So for heavy data applications, UI-based automation might not be a very good way to go. So what I can definitely recommend at top of my head is basic navigation based on the rules that you can definitely automate. Don't validate on the content itself because the data can keep changing. Unless you've got a seeded database which you know the data is not going to change, so you're starting the application running some business rules based on that standard static data that you are aware of, only then can you validate the aspects of what is ending up in the report as well. Still, don't validate it from the UI perspective. See if you can get a dump into a CSV or some such structured file, which you can write some utilities and validate much more faster behind the scenes. So check for basic functionality at a UI level. Everything else, try to find out ways how you can maybe export that report into a CSV and validate, compare it based on what is expected and what you see over there. That might also help. In some
Case study from the Selenium conference, we had presented one case study on for a business intelligence application for analytics application basically. We moved away from Selenium to kind of doing all of that under the UI. Yeah. There is a video online if you go to the Selenium conference, you can see there's some examples as well of how we done that.
So I just need to search on the Selenium conference.
Yeah,
Selenium Conf YouTube, and you should find this somehow.
Yeah, because in BI I have specifically seen that it's more manual and very few content about the automation. But
when you search for automation, you might not find because UI automation, as Anand said,
Yeah.
is not the right strategy over there. You have to look for actual testing strategies for
Correct.
BI application, and you will find a bunch of patterns.
Yeah, and maybe we can talk post this session. There are some other things you can potentially try from the UI side, but again, not going through validating at UI level. But how do you make it easier to get below the UI? You could potentially do that. Okay. So I guess we are out of time, but it's lunchtime. We can continue talking if anyone wants.